Okay, in this video I'm going to discuss climate change and a few other considerations. First of all, the greenhouse effect. This is really important. Hopefully you've already watched the video, but I'll explain it briefly here. The sun emits mostly shortwave radiation. Shortwave refers to the wavelength. It's a relatively short wavelength, which means it's relatively powerful, which is one of the reasons why it can reach all the way from the sun to the earth, 93 million miles away. Um, the important thing about shortwave radiation in terms of the greenhouse effect is that it can pass right through the greenhouse gases. So as you know from the video, the greenhouse gases are all throughout the atmosphere. Well, shortwave radiation basically goes right through the greenhouse gases, although some of it is reflected. But in terms of the greenhouse gases, shortwave goes right through. Okay, so when the shortwave hits the surface of the Earth, some of it will bounce right back. So if it's still shortwave radiation, it's most likely going to travel right back through the greenhouse gases and out to space. So that's what's called reflected. Okay, so that's reflected. Now, a significant portion, about 50% of the shortwave radiation is actually absorbed by things on or near the Earth's surface. If it's absorbed by something on or near the Earth's surface, it is then radiated out as long wave radiation. Okay, so long wave infrared radiation. So if it's reflected, it bounces right through. If it gets absorbed, it's radiated as long wave, okay? The key here is that the greenhouse gases can actually absorb this long wave radiation pretty readily. And then if it absorbs it, then it's going to re-radiate back out in all directions. And just by law of averages, about half of that is going to go back toward the surface of the Earth. Some of it will go back out to space, but that is how the atmosphere and the greenhouse gases in the atmosphere act as kind of a blanket, but kind of a greenhouse, if you will, in that it allows certain types of radiation through, and then certain types of radiation is going to radiate back toward the surface of the Earth. So that's the basics of the greenhouse effect. Now, in terms of greenhouse gas emissions, we are most concerned with carbon dioxide, which I'll go over in a minute here. But there's something called the carbon cycle, which you were probably introduced to a really long time ago in science class in elementary school. But the bottom line is that I am not at all concerned about the numbers here. You know, this mass of carbon. So this is gigatons. So these are billions of tons of carbon dioxide, these numbers. I'm not worried about the numbers. What I want you to understand is that carbon dioxide is constantly being cycled in and out of the atmosphere. Okay, so it's being, trees and other vegetation grow, they suck in carbon dioxide. When they die, they release the carbon dioxide. When they burn, they release carbon dioxide. The oceans are a big absorber. The land itself is one of the biggest absorbers of carbon dioxide, but it also releases some carbon dioxide as well. So the key is it's going back and forth all the time. All right. Now, if you look at it again, I'm not concerned about the numbers. Sorry about that. I'm not concerned about the numbers. The oceans and the biosphere, it's a lot. Okay, so this is 770 billion tons, give or take. Now, anthropogenic is the human-caused emission. So anthropogenic means caused by humans. We only contribute a very small portion relative to this huge amount that goes in and out naturally. So the Earth, without humans, would still emit and absorb billions and billions of tons of carbon dioxide. And we as humans only emit a tiny amount relative, okay, to nature. So why is this important? And the key is that it's actually, what it does is the Earth naturally effectively balances the carbon cycle. So the carbon budget is balanced, if you will. And the concentration of carbon dioxide fluctuates slightly for the most part, but has been stable for thousands of years before people really got into the picture. So the net impact of humans and their relatively small contribution is that the carbon dioxide concentration has gone up over time. This is not open for debate. This is actual measurements from late 1960s, late 1950s through today. We've been measuring it directly. Consistently, the CO2 concentration has gone up through time. Okay, so this brings me to important point number one. We know for a fact that greenhouse gases trap heat in the atmosphere, okay? In fact, without the greenhouse effect, life on Earth would not be possible. primarily because if the greenhouse effect were not happening, the Earth would be on average around 60 degrees centigrade colder in general, or on average, which means liquid water could not exist. So that basically precludes life as we know it from happening. Anyway, the point here is anybody in their right mind does not debate the fact that greenhouse gases do what they do. Okay, we know this. We need it to survive. So what are the greenhouse gases? These are the primary greenhouse gases: carbon dioxide. We have methane, nitrogen oxide. Actually, water vapor is, and chlorofluorocarbons. If you look at the relative, this is just the U.S. contributions to greenhouse gas emissions, but globally it's very similar. Something should jump out at you. Carbon dioxide is far and away the main one. Methane is also, pretty big slice here. And then nitrous oxide and some fluorinated gases. The two that we're most focused on are carbon dioxide and methane. But the biggest one that we're focused on is carbon dioxide. And just to give you an idea, the concentrations in the atmosphere, so this is your concentration in the atmosphere through time. This is, the common era here, so 2,000 years ago. You can see that the CO2 levels, the methane levels, the nitrogen oxide levels, they fluctuate. But through time, they've been relatively stable, right around late 1700s, early 1800s. Clear trend, exponential growth. What happened here, of course, is the Industrial Revolution. This is when we really started to modernize globally, using a lot of fossil fuels is primarily what it boils down to, okay? And so carbon dioxide and methane are the two we're most worried about. Carbon dioxide is the primary one because A, it's the one we emit by far the most of, and B, it's the one we have a lot of control over because, as we'll look at in a minute, the main source is energy. So a few other things to note. If you see the term ppm, that just means parts per million. That's a concentration. Parts per billion is also a concentration. Global warming potential, and this was in one of your readings. This is actually important because even though carbon dioxide is the one we're most worried about, methane is actually 20 to 30 times as potent in terms of global warming potential. And so this was in your reading, but basically this is the global warming potential is can usually take an over 100-year period, and it integrates the sort of potency, so how good the greenhouse gas is at trapping heat, and also how long it lasts in the atmosphere. Carbon dioxide will last, easily can last over 200 years in the atmosphere. So as you sit here listening to this presentation, you could be breathing in carbon dioxide that was emitted during the early years of the Industrial Revolution when they just invented the steam engine. So carbon dioxide really can stay in a long time, has a really long residency period. Methane, even though it's a very, very potent greenhouse gas, it's much more powerful in terms of potency than carbon dioxide. It only lasts 10 years, 12 years, 20 years tops. Nitrogen oxide is pretty potent, and it lasts a relatively long time, but there's really not a whole lot we can do about the nitrous oxide, and it's also not a huge component. Okay, so if we take a look at these are the U.S. carbon dioxide emissions by source. Again, CO2 is the primary one we're worried about, both in the U.S. but also globally. And if you take a look at where the emissions are coming from, we have electricity, transportation, industry, residential, and commercial. Guess what all of those have in common? They have to do with energy. And the big culprit here is fossil fuels. So this little 6% slice is your non-fossil fuel combustion. Fossil fuels, if we want to combat carbon dioxide emissions and therefore the likelihood of climate change, we need to reduce our fossil fuel use. So that's really what it boils down to. And there's a lot of different strategies you can employ. We can do energy efficiency, energy conservation, renewable energy. CCS is kind of a new technology we won't get into. And then even though it's helpful, the land use change is last on the list. But the key here is that hands down the best way to reduce emissions is to reduce fossil fuel use. So this brings us to important point number 2. So remember, number 1 is that we know that greenhouse gases do. Number 2 is that we know that humans are causing concentrations of greenhouse gases to increase. These are not debatable points. So really, as David McKay puts it, if you're riding, this is an analogy he uses. He says, look, if you're riding a motorcycle at a high speed and don't have a map, but you think you're close to a cliff, wouldn't you slow down? So go ahead and press pause and think about that analogy and how it relates to climate change and carbon emissions. What it boils down to is that there is some debate about the accuracy and of climate change, like how much are we impacting the climate. But you'll never hear me say that we are changing the climate, but I think it's important to understand that we know what greenhouse gases do. We know that humans are causing concentrations of greenhouse gases to increase. So, you kind of put two and two together. We're likely, we're playing with fire here, no pun intended. And so, his analogy, of course, is that if we have a, we have a pretty good idea that we're getting close to a cliff, which the impacts of climate change are so severe that it could be likened to falling off a cliff, that maybe we should just sort of take the precautionary principle here and kind of slow down our emissions. So I'm not going to go over this. You can press pause and read it. But basically, the evidence is becoming clearer and clearer that that we're changing the climate. We're basically positive that the overall trend across the globe is warming, and that one of the important things that we don't think a lot about is that the ocean acidity is actually going up. That's what this line is your pH level of the oceans. It's increased. The pH level is decreasing, which means the acidity is increasing. This is actually the concentration of carbon dioxide in the ocean. So this is all bad. You can go ahead and read through this, but basically the evidence is really clear that we're probably impacting the climate. Now, some of the probable impacts, again, I'm not going to go over these in detail, but you can click on this website. This was in your reading. A lot of really bad things will happen if climate change happens, as we think it probably will. And that brings me to important point number 3. So we know what greenhouse gases do. We know that we're emitting greenhouse gases. And one of the really nice, or excuse me, not one of the nice things, one of the important things is that the impacts of climate change are so bad that it's worth, undergoing a little bit of short-term hardship. So, it's going to take there's going to be a transitional period to move to renewables and energy reduction and so forth, but the impacts are so bad that it's worth, in my opinion, in many people's opinion, taking this precautionary principle. In other words, we just don't. The worst thing that could possibly happen is that climate change is being caused by humans and we don't do anything. So, in order to prevent that eventuality from occurring, the best thing to do is just kind of slow down and say, all right, let's just avoid the worst case scenario. And I'd like to submit to you sort of an additional note, and that is that there's so many positive impacts of reducing fossil fuel use that it's not like it's going to be, fire and brimstone and mass chaos. I mean, it's going to be an adjustment period, but when all is said and done, if we move off of fossil fuels, we have cleaner air, more energy security, et cetera, okay? So there are some good impacts of moving toward away from fossil fuels. And just to give you an idea of who is emitting the most, China is now, global climate emissions here, sorry, China is now the single biggest emitter. USA is number 2. And then the whole European Union is 13% and so forth. So you can look these through, but the key here is that China is the biggest, USA is the next biggest, and this just gives you a feel for the sectors that are causing climate emissions. And so I think it's important to look at not only who is emitting the most, but who is emitting the most per person or per capita. This becomes really important. Even though China is emitting by far the most, on a per person basis, which is your y-axis here, the United States, we're about, the lead. We're actually, this has dropped a little bit since this map was made, or this chart was made. And you can't see it down here, but this is your population. So the bottom line is China has about 4 times the people of the United States, so of course they're going to emit more carbon dioxide. But on a per person basis, they don't. So you also want to look at historical emissions because, again, carbon dioxide can last 200 years or more in the atmosphere. So if you look at the overall per person emissions over in the history of the world, Western countries are far and away the biggest emitters. And that's it for the climate change portion. In the next short lecture, I'll discuss externalities.